Hello everyone. Today we will be covering functional programming in Python, and the topics that we'll be covering are Lambda, maps, filters, zip functions, then reduce, and also we'll be covering the arbitrary arguments and arbitrary keywords argument. Why we in general use this function? They help you to make your code more readable, and you can you can structure your code well. Let's get started. Um, I'll be sharing this notebook in the end, so you guys just have to, if you guys want to go through it, you can easily go through it. The first function that we'll be looking into is Lambda. This is like a normal function that you create in Python, right? So if I just let me just restart this. Um, uh, Let me disconnect and delete the runtime, okay? And we will be running the complete notebook again. Great. So the first function, as we see, it's a normal Python function, how we create it. And this is the way you pass the parameter and get the output, right? Now, how to do it with Lambda? In Lambda, you have to you have to define it in the sense where X is the input, and then you will be performing some output. The way you did it in before, just you have to do it in this manner, and if we run this code, you can get the output in the same manner. Now, one way to define is to save it in a variable and then call it this way. Similarly, we are getting the square of 5 as well. Then, if I look into this, just make sure of one thing. Here, I commented this code out. So, just to show you guys, there is no need to mention return over here. So, all you have to do is just define the lambda function as this, right? And then the rest of the thing will already be there in the inside the lambda module itself. So there is no need to mention return here. So let me comment this out and let's move forward. In the next section, we see that let's say you have to pass two arguments, right? So the way to pass the two arguments is so make sure like this is like a complete variable we defined. So there are different ways that you can do it. Here I defined it inside a variable and I'm calling it in a like a function. Similarly, you can do what you can do is you can define it in parentheses in the brackets and then you can call it accordingly. So 2 and 3 I'm passing in x and y and I'm getting like 2 to the power 3. Similarly, I get this 23 to the power 3 and if I run this, let me run it. These are the outputs that we get. Now here we are calculating the floor function, and I hope you all guys are aware about what floor is. And we are just checking like if it's like y is greater than 0, then we will get a floor. If it's not, then we will generate a message saying that y cannot be 0. So if I run this, and that would be 7, and this would y cannot be 0, right? So here I define my lambda function, and then I'm calling below, right? Now coming back to the next point, so here you can see if let's say you define lambda and just return it as 10. So this would be a true value and it will return always I mean whatever you mentioned. So here I'm mentioning as 10, so it will return 10. So without any specific argument here, you can directly do this as well. Now next would be that I want to discuss with you guys is this argument arbitrary arguments. We'll be discussing them later also. It's like I just want to integrate them with the lambda function. So here, just have a look at it. We'll be passing multiple values in my lambda function along with the arbitrary values. So 3954 I will be passing, and all of them are getting summed over here, and we will be getting 21 as an output. Great. Let's move forward then. It looks great. It looks fine. We run 7 and 4. We get 11 as a sum because we are returning sum here. And then let's calculate a factorial. So in a general function, you are aware like how to calculate the factorial. We are using lambda here to calculate the factorial. We'll be we will be creating this particular function over here, which we will be calling with x into effect x minus 1. Effect we already defined here. Now, if my x is greater than 1, we will call this, else we will call 1, and we can get the factorial. So you can get the factorial of 13, or if you want to calculate the factorial of 3, you can get that as well. Now, moving forward, I hope like you guys are aware about the sorted function in Python. So sorted, if you in case want to sort your list and it is having some dictionary inside it, you can pass it in this way, in this manner, where your student would be the variable that you define, and then you can mention lambda inside your key, and whatever you pass inside it, it gets sorted according to this. Reverse, I mentioned it too, so that it gets sorted in descending order. So here you can see you get a sorted value. So all this is in Lambda. Let's move to the map module. Inside the map, it's nothing. Just we will be mapping our list with according to the Lambda we defined. So I hope now by now you guys are aware about what Lambda is. Here we are passing the list, and then for each value inside the list, we'll be multiplying it by 2. Now the map function return a map argument, a map object, right? So to convert it into a list, what we did was we just did a list with the brackets and we get the list output as this. So once I run this, you can see we will get list as an output. So map next, this will be what we are doing. We are multiplying each element of the list by 2. Here we want to take the power of each element and by 2. So we will be basically doing a power of 3 by 2 to the power as 2. And here we get 9, 1, 16, and 4. So, okay. Now let's move forward to the next example. We have a list, and within list we have another two lists inside it. And now, so we all are aware about this thing, right? When we multiply any list element, when we multiply any list with an integer, it gets you can say add or append. The list gets appended to the previous list. So initially we have 1, 2, 3, and 4. Now we will have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Great. Now let's move forward. Uh, Check this thing out. So inside what I am doing is I am uh, implementing a lambda function, and then again I'm doing the lambda function on the list. So let me break it down. First, what I did was I created a lambda. Okay, x is my input, right? So and what I will be returning, I will be returning its multiply by 2. So multiply would be my list gets appended at the end, right? And from what I am doing that, like what would be my input? If you can see it out here, there is a lambda again, and list two is something like list within list, right? So I take list here, right? I return this list in my lambda as an input and it gets multiplied. Then again, I take second element of this list, which is this one, okay? And then it again do the same thing. So if let's say let's change some variable values here, do something like this, right? And now when I run this, you can see that first your first list gets appended, then your second list. Okay. Now let's move forward. And the second thing, in the second 2.3 check, here you can see this is the same kind of another same kind of function module we are using, that is map function. And here we change this a little bit. What we are doing now is we are getting the power of each individual element inside the list. Okay, so if I run this, you can see that I'm now getting the power of each individual element that are there inside the list. So you can go through it, just have a look around it, and I hope you'll be able to easily understand what and how it's working. Great. Now let's move forward to the filter module. In the filter module, what we'll be doing is we will be filtering out the thing. So if my mod 2 equal to 0, then I will be filtering those values from the list. So for example, let's say I have a list like this. This is a list that I am taking as an input, and I want to filter this based on this function. So if it's even value, then it will return me, and else it's not. when I run this thing, I will get all the even values. Then in my next thing, you can see here I'm just returning a true value, right? I'm just returning 10 irrespective of what the input is. So as I'm getting a list of 3, 4, 5, and 1, we are getting the same value as output because I'm doing 10 over here. So I mean, it is not in general we use in the coding part, but these kinds of questions are important when you do or appear for some test or something. Great. So let's move forward. The next module that we'll be looking into is the zip. So zip basically what it does. Let's say you have two two variable. One is age, another one is child name. Okay. So inside your age data type, you have integers, and inside your child data type, you have strings. Okay. Now, what I did, I zipped both of them. Great. And then once I check it out, it you can see over here each corresponding value will be assigned to that particular each corresponding value in my child name is getting assigned to my age, right? So here you can see we get a dictionary and we converted it to the dictionary and then we have a key value pair here, right? Now, similarly, what I want you guys to have look at, which is important here. Here I converted into dictionary, right? And the second one I converted it into basically list. Let me run it from here. Okay. And now you can see I have basically list over here with tuple inside it. Okay. So it's up to you, like how you want to change it and what data type you want in the end. Great. Now let's move forward. So there is another this there's one more question over here. If one of your variable that you want to zip is having two values. So my age is having only two values and my child name are having five values here, right? So when I zip it out, I just only get two values. So the one initially that are there, they will be zipped with my initial values and this will not be considered. Right? So this is my zip module. Let's move forward with the reduce one. In reduce, what's the differences? First, you have to import it using func2, and here you will be reducing your complete list to some value, right? So if we see this example, we are using Lambda, and what we are doing, we are summing it up. So all the elements inside the list get summed up. So 4 plus 5 plus 2 plus 6, right? So all of them get summed up, and you will reduce it to 25, right? Great. Now let's move forward with our next example. In this example, as you can see, we are doing the same thing, but it's a little complex than the previous one. You can just have a look around it, and you'll be able to understand like what and how we are getting the output. Great. Now let's move forward with the arbitrary arguments. What are arbitrary arguments and why we use it? So, for example, you are having a function, right? Some arbitrary function or some ABC function in which you have less of an idea like how much argument you may get in, right? So there may be a function, let's say you specify that two of your arguments are must, which you must need for a function to call, and then you pass the rest of the argument, which you are not sure that can be based on the input, right? So this is the way you pass it. It's asterisk with any particular name that you want to give it. And if you check the type, it's a tuple type. Okay. So if you see when I run this particular thing, you can see 3 and 4 are assigned to A and B. So my A is 3, my B is 4, right? And inside my argument parameter, I have 2, 5, and 2. Great. So now if I print it out, you can see it's a tuple class and you are getting some output over here. Great. Now what I did was I sum it up and the argument can be of any length, right? So in the previous one I assigned it to length 3. Now I assigned it to length 1 and I am still getting the output. So arbitrary arguments are generally used when we have sometimes we want to build a function out such that we are not sure about the how much data size we will be getting in. Great. Now let's move forward. This one is just to tell you guys that it's not mandatory to mention it as ARGS, right? You can give it any name, any ARGS name that you want to give. But in general naming convention, we go with the ARGS so that it's just kind of a little naming convention that you can go with, right? Now, these are the arbitrary arguments that we use. Now, moving forward to the keyword arguments, arbitrary keywords argument. Now, similar to the arguments, there we will be getting a tuple, right? Now, in this, what we are specifying, we are specifying them as a keyword argument, right? Key and values. So, if you can see, let's say, similar to the arbitrary arguments, right? In keyword argument or Kwargs also, we are not sure about the input, how much we will be getting, right? So, as you can see here, my A is assigned to 3, my B is assigned to 2, and my quarks are assigned to C and D. So if I run this particular function, you can see I will get a type dictionary. So my quarks would be of type dictionary, and we are getting this as an output, right? So I hope now you guys be able to understand all these concepts, and you guys can integrate it in your daily code, and will help you to build a better logical structure using them. Thank you so much, and hope to see you in part 2 of functional programming. So, thank you so much, guys.